So I'm the director of the new nuclear technology program at Roane State, and as part of that, we're very interested in workforce development across our TBR partners, and here at TCAT, we had the concept to do 3 nuclear modules to give the TCAT students a little bit of a advantage when they interview, if they're interested in working in places like TVA, nuclear sites, or working in Oak Ridge. 4 primary lanes are happening. One is that the new SMRs that TVA is interested in building at Clinch River. There's a lot of money right now that's being put in from the government for cleanup with UCOR, and there's an increase in activity at Y-12 with the DOE, National Nuclear Security Administration, and then ORNL, of course, doing a lot of research today. So with those 4 lanes, there's a need for technician level, at the TCAT stage and at the 2-year stage within our nuclear sites in those 4 areas. Yeah, so the final experiment in the afternoon of the last day is going to involve emphasizing the time, distance, and shielding of radioactivity. We have a setup to where we have a circle drawn out on asphalt, and we placed a container of simulated nuclear materials that's identified as the radioactive. And the students are going to be giving a mystery packet which contains rope and a bungee cord, and they're going to have to figure out and work together to tie those ropes to the bungee cord, stretch that bungee cord out. The goal is to lift the container up and place it on a simulated lead shielding box, and so they'll have to place the container, lift it up, place it on the bottom of the lead shielding box, which is simulated lead, and then lift up the lead box part and then place it over the container so they're containing the radiation. So the rules of the contest, or the rules of this would be, is that they could do it as quick as they can. That would be the time, being exposed to the simulated radiation. Being outside of the circle, that's distance. And the shielding would be is understanding that there would, in a normal situation, you would have a lead shielding that would be covering that up. So that's the activities. We hope, to have a winner, that does it quickly and figures out what they're doing. It's a little bit of team building on that too. So week 1, we covered the basics, making sure each student understood the different types of radiation, knowing the difference between fusion and fission, and the uses of nuclear energy and the uses of radiation and the uses of isotopes. Number 2, we focused on some more deeper specifics in commercial reactors. After the lecture in the theory of measurements and all the things that are necessary in radiation measurements, that AMSE coordinated a bunch of radiation measurement experiments. Why it's relevant is because there's an increase in activity in nuclear in the region, especially with the interest in nuclear power, clean energy. Clean energy is the big driver in my mind. With the closure of our coal plant here in the Oak Ridge area and the activity that's going on for small modular reactors, to me, the right thing to do is to proceed with nuclear power. It's clean. It's a lot of electricity in a small footprint, and we know about it. I think our experience in commercial reactors and our experience in nuclear is very high right now, and it's with the increase in automobiles and nuclear and powering homes and powering industry, especially with computing power, we're going to need clean energy for this area and then across the United States.